Okay, hello everybody, and welcome to today's OSMINE webinar with Rockwell Automation, Digital Transformation in Mining, Time for Reflection, Evaluation and Enhancement. I'm Sam Sakasiris, the OSMINE Membership Manager for WA, and I'm pleased to be your host for today. Before we begin, on behalf of OSMINE and Rockwell Automation, I'd like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. I also acknowledge the traditional custodians of the various lands on which we all meet today. For this webinar, I'm joined by Rockwell Automation's Kumar Parekh, Digital Consulting Principal, and Joseph Plant, Industry Consultant, Mining and Metals. Following the presentation, there will be time for audience Q&A. You can use the Q&A button at the bottom of your screen to send through all your questions at any time during the presentation. This webinar is being recorded and will be shared with all attendees. So without further ado, I'd like to now hand it over to Kumar Parekh and Joseph Plant. Welcome, gentlemen.
Thanks.
Thank you.
Thanks, Sam. Just to start with, what I would like to do is have a quick intro. Joe, do you want to just go quickly first?
Yeah. Hi, my name's Joseph Plant. I'm part of a global accounts team for Rockwell Automation, and my job is to focus on the mining and metals customers and understanding what the industry challenges they have as customers and how, as Rockwell Automation, we can help them.
Thank you, Joe. My name is Kumar Parekh. I'm the Global Principal for Digital and Data for Mining, Metals and Cement. I'm based in Brisbane, and have been with Rockwell for over a year now, and have a bit of a background in mining and metals globally with some of the large organizations around. So look, today's focus is going to be on digital transformation in mining from a 4.0 perspective. For people who are familiar with Industry 4.0 or not familiar, I'll just give a quick background on what exactly that is from an Industry 4.0. So essentially, mining 4.0 is basically following up on Industry 4.0 with a focus being on automation and connectivity. In our mining industry, mainly automation has been happening on the ground, but from a connectivity perspective, we have not done as well as we could. So mining 4.0 focuses on automation and connectivity, that is the automation and the data, with the goal being efficiency and agility and higher productivity. You will hear me talk a few times about the 3 diamonds, which is higher throughput, predictive maintenance, and process optimization. This is the cornerstone of our mining industry, where every company is looking out for. The technologies typically involved in this mining 4.0 are IoT, big data analytics, and a lot of automation in terms of using advanced technologies. The benefits are clear. It's around reduced costs and improved quality. Industry 4.0 builds upon 5.0, and hence mining does. So mining 5.0 is about introducing the human part again back to it. It is about human and machine collaboration with a focus on sustainability and reliability. And it uses the same technologies, but takes them forward and puts in a human-centered design into place. What it does is that it helps have greater job satisfaction, especially in a world where we are struggling to basically attract more younger people into our industry, and increase safety and a better environmental impact. So this is the gist of today's, and we'll introduce some certain technologies on this. Now, Rockwell Automation we have over 29,000 employees with a lot of with over 100 countries, a presence in over 100 countries, with the sales of over $9 billion and 29,000 employees. We have a very strong capability globally and locally in Australia, New Zealand, and Asia Pacific. We have three large innovation centers. One in Monterrey in Mexico, one in Pune, India, the other one in Bucharest in Hungary, and a presence throughout. Now, talking about mining 4.0, talking about digital transformation, some of the key things that we have realized, we are over 100 years old as a company, and we realized a few years ago that we also have to change. Change is a constant, and as part of that, we have invested over $3 billion in making a lot of acquisitions around different digital technologies, different consulting technologies, robotics, and the ability to deliver at a large scale, which is required for transformation programs and projects. Now, what are the key challenges and priorities? So I've just spent like over a month in South America and North America, and we met a lot of new leaders, existing leaders in a lot of mines and mining and metals companies, cement companies. What has been clear is that what are the challenges they are facing? What we have heard is that the challenge is the volatility of pricing and the iron ore, for example, the prices of coal, prices of other base metals in the market, and the access to resources. Existing resources are getting degraded. So, for example, a mine which was being mined for gold earlier is now shifting to copper because the rate of gold finds have become very low, and the capital and operational costs. This is very key today with inflation, etc. What has been happening is that these costs have really gone up. At the same time, we have a crisis on our hands in trying to attract and retain talent, especially the younger cohort. Now, what we are doing is that as a result of this, there are certain strategic options that we are basically advising our clients on, working with them to actually deliver those, which is having an integrated view of operations, ability to process lower grade ores, and implementing effective and operating and maintenance strategies. Again, going back to the 3 diamonds: higher throughput, predictive maintenance, and process optimization, and leveraging the technology to make this happen. Now, one of the key things that you will see is as a result of what we saw before, the challenges, what we have found is that our clients are now focused on the following: preserving IP as key personnel retire or leave, because a lot of people in our industry have got 25, 30, 40 years of experience, and they are coming to a stage where they will be leaving the workforce, or they are actively leaving the workforce. So preserving that IP, this is important. Industrial data operations. In other parts of the industry or other sectors like financial services, this has already been solved from a data operations perspective, but the mining industry is behind the 8 ball on this. So this is a focus: connected and autonomous operations, and all leading to the 3 diamonds on the right-hand side: process optimization, higher throughput, and predictive maintenance. Now, one of the key things that we have been talking to clients about is that either they are excited because they are starting on a greenfield site, a new site, or they are a bit fatigued because they have stalled on digital transformation. The stall might have happened because of lack of resources, higher costs, the lack of integration between IT and OT data, a lack of availability on part of the operations team to actually be able to focus on transformation. There are a number of reasons, and we work with clients in both of this. A greenfield sites, they want to be digital ready when they start, so they don't make the same mistakes that were made earlier. And brownfield sites, it is more about the transformation has stalled. How do we kickstart it? How do we help them chart out a path out of that at a lower cost and more efficiently? Now, looking ahead, the important things, what are the technology trends that are driving towards mining 4.0 and 5.0? Now, most of us have heard and have experimented with generative AI. Most of us have actually used contextual AI. Most of us use, Siri or some sort of chatbots, etc. The trend which is taking us towards 4.0 in mining and beyond is the convergence of generative and contextual AI. This is what is going to be, is predicted to happen. That right now, generative AI is extremely powerful, but with some drawbacks in terms of data lag. It sometimes hallucinates because of data, and so the way forward is the convergence of these 2 technologies. The second trend is around trust in data. It's a question that is very simple. When you ask people on the mine site, you ask people in maintenance, in operations, that do you trust your systems and the data it generates and the processes? Because if your salary, if your wages are dependent on it, if your work is dependent on it, do you trust it enough so that you could actually automate it? In most cases, the answer is no. They don't trust it enough because the processes are not clear, they are not transparent, and the systems and technologies do not integrate well. The third one that we focus on is cybersecurity, but cybersecurity not the way we see it today, but cybersecurity as we see it tomorrow, which is a continuous threat exposure and management. Now, it's basically based on evidence-based security optimization and across the teams. That means everyone in the organization is responsible for it, and the technologies that are employed for it are appropriate on that. The fourth pillar or the fourth trend is industry cloud platforms. What it means is that currently we use SaaS, PaaS, and IaaS. Industry cloud platform is more focused on a specific industry, because each industry, like mining, for example, we have specific needs. And the current technologies from a perspective of AWS or Azure that is available, or GCP or IBM, for example, they are all generic technologies from a cloud perspective. There is a layer above on which many companies and clients are now starting to look at is industry cloud platforms, is industry specific, that is mining specific industry cloud platforms. The fifth pillar or the trend is democratized AI. This means it is going one level above what we call as data democracy, which is access at the plant level, at the processing level, at the mine site. Do the people have access to AI and the information behind the AI and the skills to be able to use that AI for their daily work? And lastly, but not the least important, is the augmented connected workforce. Why this is important is that we are always talking about connected workforce. Here we are taking it one step ahead. We are saying that we are going to be using technology, workforce analytics, and a skills upgrade. Remember, it's mining 5.0. It's more human-centered. And so be able to use the technology, workforce analytics, and skills upgrade to have a connected and an augmented workforce. So these are the technology trends which are currently being driven by current client demands and the real market forces at play. Now, digital transformation to mining and beyond is, at the end of the day, it is about a pursuit of an autonomous closed loop operating system. What it means is that if you look at this, what we are presenting on the screen here, it's like this. It's about the maturity curve. In simple language, what it means is that if you can measure it, you can monitor it, you can report it. If you can report it, you should be able to create business intelligence on it. If you can do that, the next step would be to be able to diagnose problems. After that, you want to be able to predict. After that, you want to be able to be prescriptive in terms of the problems or AI problems you are trying to solve. And finally, what every mining company aims for is nirvana, which is autonomy, having an autonomous connected mine, which can be remotely controlled from an IROC or a remote operation center, which is remote. It doesn't mean that people who are working on the mine sites will not be required. It simply means that the way of managing is different. And this is the typical maturity curve of how many of our clients are approaching this. Most clients that we meet are somewhere between descriptive and diagnostic, or up to predictive. There's hardly any clients who are able to use the full power of prescriptive analytics to be able to again look at the three dimensions of that, which is higher throughput, predictive maintenance, and process optimization. Now, how do we actually bring this to life? How do we actually make this happen? These are the 8 pillars of the key technologies which will drive towards those 3 dimensions. One is having a digital supply chain where you are using AMRs or AGVs or advanced robotics and applying IoT technologies to manage your logistics. You are using planning and resource optimization on the shop floor, on the mine floor, on the mine site for your resources to improve your productivity, ensure availability. Then it's about advanced simulation and emulation, when you are designing a new mine site, when you are designing a new plant, or an R&D plant, or a demonstration plant, as is happening at many companies in the world, they might be constructing a new lithium plant, for example, or a demonstration plant. The use of advanced simulation and emulation means that you actually are able to do it using digital twins, do it virtually, test it, and commission it virtually before actually doing the work on the ground. You save on cost, you get more accuracy, is more safer. Then it's the next one is around closed loop optimization, as I said earlier. It's about using prescriptive machine learning to improve your process control. So later on, my colleague Joe will be talking to some of this in terms of the technologies that are available currently. And digital performance management. Overall equipment efficiency is important. It's about able to, if you have the data, you can monitor it and you can change it. Then, and predictive maintenance, one of the 3 diamonds that we keep on hearing about. It's about using industrial artificial intelligence to detect and predict faults. Is being able to have the right data at the right time to make the right decisions. And finally, from an Australia perspective, from a New Zealand perspective, from a local perspective, energy management sustainability. This is key for us from a regulation, compliance, and from a government perspective. Most of our organizations are committed to energy management and sustainability. The ability to actually monitor your scope 1 to 3 emissions is key to this. And finally, the connected or augmented workforce. If your people are engaged, empowered, and they're connected, they have access to the information, then that is they are productive. Each of this on the bottom you can see. All this is only possible if your IT and OT are working together. There's a foundational architecture and data management, which is foundational to it, which will actually enable the above 8 pillars to be able to use, to be able to deliver predictive maintenance, higher throughput, and process optimization in your mining operations. Now, our approach is, what we do is that, like, some of the key things that we are focused on, these are some of the clients who we work with. We are very proud of the fact that more than 50% of our staff are basically with advanced degrees. They are not only engineers, but they have degrees beyond engineering, basic engineering. And we focus across digital delivery. We have the software control and devices to be able to enable that, and the foundational decarbonization and new energies technologies, which we work with our clients and our partners on. Now, many of you will be familiar with this level 1 to level 4 architecture, which is typically happening in a industrial architecture space. And our focus is to make a small start. To make a small start, look at a minimum viable product, deliver value, and do that. So for example, from a predictive maintenance perspective, we would be looking at, we will separate out the fixed assets, we'll separate out the mobile assets, focus on what is important, and then deliver value only for that, which basically opens the gate to the next stage of implementation. Now, how we actually approach this is, we approach this in a number of phases. The first one is discover and assess. So when a client comes to us and say, we are building a new mine site, we want to be digital ready on day 1, how can you help? So we go across, we help them build a strategy and a roadmap. And then we take up specific use cases, which have been defined in the first phase. We help develop them into a minimum viable product. And in phase 3, depending on the success, we actually help them scale up. This is the typical way we work. We have worked with this with clients globally in many countries. It's a proven safe way of doing things. The important part is that many times OT and IT, this process actually helps develop an operating model for them, which ensures, how will a metallurgist, how will a geologist, how will a maintenance manager or a plant manager, how will they actually work together from a responsibility and accountability perspective? It's clear, it can be done. Now, some of the proof points and this pack will also be put up on the OSMINE website. So this is an example of where we have done what we call as a digital value acceleration assessment, where a large organization wanted to self-fund a facility upgrade through digital transformation, but they wanted the transformation to pay for itself from the first phase itself. So we worked with them and achieved the operational efficiencies by implementing the digital solutions. The results were, for their operating model for their fleet, then capture the data more effectively to improve their operations. We increase the collaboration and the value first, or the minimum viable product, which delivers value. We work with them to achieve that. So this is how we actually help them construct a program which they could actually execute for achieving digital transformation. This is a live example of something that we have done for one of the world's largest clients, and these are real numbers. We have helped them achieve up to $285 million per annum in actual benefits. We have helped them reduce their carbon footprint by 570,000 tires per annum, and a reduction in downtime. What we did was that we applied advanced algorithms using our data science capability and help them. When you do manufacturing or you manufacture a tire, we focused on the threads that you see on the tires. They are the ones which, whilst manufacturing, there's a lot of inefficiencies in that. By using our algorithms, those inefficiencies were reduced a lot, and that is how this saving of approximately $285 million was achieved by our client. Now, this another example is basically AI-driven closed-loop optimization across 11 sites. I touched upon closed-loop optimization earlier in terms of the move to mining 4.0 and beyond. So this is where we basically worked with a client who were looking at an APC program across 30 lines and units, and we basically executed over 5 years on this. We implemented our AI-driven closed-loop optimization software, which is MPC or Pavilion. My colleague Joe will be covering this at a high level later on. And what we did is that over a period of 1 year, we produced the change in the product quality and the consistency, and hence there was a direct impact on the bottom line. The implementation just took under 1 year, and it was across the reactor section control and distillation section control. Now, what is going to be happening is that the next section will be focusing on some of our solutions, and my colleague Joe will be taking it across this and talking to those. Over to you, Joe.
Thank you, Kumar. So now we're just going to talk about 3 specific offers that we have at Rockwell Automation that help in our mining customers in the digital transformation approach. Now, I'm just first of all going to talk about what we call mining operations management. And this is about understanding the type of data that we need to make decisions on at a level across the mine and across the value chain, from the pit, through the crusher, through the mineral processing plant, through the logistics chain into shipping. And there's lots of different data sources and different pieces of information that need to get that information. There's ERPs, there's coming from the process data via historians. There's quality lab results that need to come from a LIMS system or a laboratory system. And there's fleet management systems that actually describe, where trucks have come from, what's happening from that process, and where the material that is actually coming from the ore body and how it's going into that mineral processing. By integrating and understanding all those different types of data and how that data is not always available at the time you need it, and sometimes it changes after the fact and you need to come back later on. So having a model that is going to be integrated and deliverable through that process will help us understand the types of information that's going forward. I think one of the challenges in this type of area is that sometimes you want to start small and you need to do an area on a particular area that maybe looks at a focus on an area of things are stopped or running, or it actually may be a really complicated logistics chain that you need to understand where your inventory is across those values. So you want to have the same platform that allows you to manage those processes and be able to grow as you are growing through that point of view. So I've got an example here of this is a global company that we've done work with. It's currently ongoing. And there's an operations management tool that was going through their processes from the mine, through their chemical processing, through the logistics chains and out through to their final product. And there's lots of different processes required in that space. And this company was doing a large transformation across their business. They were changing how they were operating and the people and the processes they were doing to do that. And they were looking for a technology system that would actually meet their requirements of how they wanted to do their business. This had many sites, and so they also wanted to standardize that, making sure that each site was going to have the ability to be able to have the same processes, and the technology was going to support that through those areas. Probably one of the key areas for them was really around production quality. So is the final product going to be of the right quality so that they can actually sell it directly to their customer? And this is a really critical process that they need to understand. There was a lot of processing required, and the control of that process was also going to require to be well controlled so that the quality of the final product was actually going to be reliable and on spec to what was going to go through that process. This project here had a payback within 1 year of their rollout, and that rollout is still rolling out to multiple sites at the moment. I'm just going to move on to another area, and this is around model predictive control. Kumar's already mentioned model predictive control, and this is a high-level picture just showing here in this example of a mill. And model predictive control is about understanding all the things that as a user we can control on the mill. There's a number of different set points that we can change, and there's also disturbances that come into that process. We don't always know what the feed that is going to come into that mill. We don't always know what the feed size is going to be that process. But we want to understand whether there's a certain amount of power or a certain amount of processes into those points of view. So model predictive control is an analytics approach, an artificial intelligence analytics approach that looks at modeling the process. And by modeling the process, it actually closes the loop and understands and not just suggests a change to the operator, it actually can make that change for the operator. And so your process can run as though you have your best operator running it all the time. You don't have to wait. And this is probably one of the problems, one of the areas here that this can help with knowledge, understanding your knowledge. So it's as though you always have your best operator running the process all the time. And part of this approach is understanding too, is like in this example here on the screen here, you can see that there's a bit of a blue line showing here. There's a lot of variability in that process that is controlling over time. And so this may be due to different skill levels of the operators going through that process. It may be due to the conditions or the temperature or the weather that's happening, or it may be due to the feed that is feeding to that process. By having some advanced process control, what we're trying to do is we're trying to reduce the amount of variability so that it is more controlled through that process. And once you get to that point where it becomes more controlled, you can then take it to the point where you can then start uplifting that process. You can actually take that benefit into a higher production rate, or we could actually done it in reverse and actually saying we're going to reduce the amount of energy that we're going to use in this process, but still meet our production targets. So this is a really powerful mechanism, and we've spoken about this at the Brisbane Innovation Workshop of some of the case studies that we've done in that space. So basically the benefits that we get out of here is that by reducing that variability, we actually make our mineral processing functions more reliable. And as they become more reliable, we can actually have a better chance of and reliability, and we trust that the process is going to be controllable through that process. And that then allows us to then uplift and get the benefit out of that process. Just a last final view of looking at some of the digital technologies of where we sort of see this across the different areas. And we believe that digital technologies have a really big, strong place to play in that. We've already talked about mining operations management. So that's about understanding the data that you need to make your decisions on. With process reliability is about making sure that the process is actually going to be reliably making that understanding what that's going, and model predictive control is a really good way of ensuring reliability of the process. The next angle there is equipment reliability, and part of that approach comes down to, from a maintenance function, is understanding, is your equipment reliable? Is it going to perform what it needs to perform? Do we have an understanding of the health? And this is where digital technologies can help us to get insights into the assets. Is it going to fail soon? Is there some anomalies that are occurring on the asset at the moment? And it could also help with the maintenance process by actually following and helping the maintainers actually doing the work and making sure that they have all the right systems that they're doing. They don't have to do it on paper and then take it back to the office and transfer that process. And one of the other ways that Rockwell can help here is also understanding what's the strategy that you need for your company, and how your mining processes is looking for that strategy and that culture of how we're going to drive those processes. So that sort of feeds back into what Kumar was talking about before, improving the throughput and the production of your asset, understanding whether the performance of the assets are actually going to be reliable, and whether they're doing the job that they were meant to do, and then also understanding how are you going to take those skills and the knowledge that from your people, and how you're going to make sure that you're systemizing that as a business process going forward. So that's probably just the three little areas there. Please reach out to both Kumar and myself if you would like to discuss this further. I believe I'm going to hand back to Sam, who will have some questions available, if there's any questions.
Fantastic. Thank you very much, gents. A really interesting and insightful presentation there. Yeah, it's now time for audience Q&A. So as I mentioned, use the Q&A button at the bottom of the webinar interface to send through any questions you would like answered. I've got a couple here to go to you guys, and either one of you can answer. You raised an interesting point about retaining IP from the workforce. How have you seen companies use digital to address the issue about keeping the knowledge?
Sam, that's a very good question. The background to this is that in talking to a number of clients globally, our industry has got a lot of the workforce has been in the industry for a very long time, and that workforce is slowly coming towards retirement or switching careers, for example. And one of the key things that clients have been asking is that when that person walks out of the door, how do we retain their IP? And we have an answer which is based on two things which we have been working with clients. One is technology, the other is managing the change. From a technology perspective, what we have been doing typically is that we have been using extended reality and emulation technologies to be able to capture the knowledge of the workers or the people who are departing from the company, and capturing that and getting it ready for use by the younger cohort who are currently joining or who are reading that kind of training. And the other part is around change management. So we use change management techniques, and it's a software approach, but it's a software approach that works.
Thank you, Kumar. Next question I've got is, from a digital perspective, what differences do you see between greenfield and brownfield mine sites?
That's a great question, Sam. There's a couple of things, and I would also request Joe to add some of his thoughts. What we have seen is that from a greenfield perspective, our clients are very enthusiastic to start on the digital journey also. They don't want us to build the Taj Mahal. What they want us to do is they want us to help them be digital ready, provide a solid foundation from a data perspective, from a OT and IT perspective, a solid foundation on which they can actually gradually build as the mine, as a demonstration plant or the mine goes to full production. So you start small and you grow and scale up. And in case of brownfield, it is mostly a case of where the transformation has stalled, or they want to increase capacity. For example, some company might be manufacturing or mining up to 350,000 metric tons a year of, say, copper. They want to go to over 1 million or 1.5 million. That is a steep rise. How do they make it happen? So this is where the difference is. The approach that we take is different in each case. However, one thing which we have seen with a couple of clients recently is that what they do is that they say, okay, this is a greenfield project. Help us be digital ready for this. Help us succeed over here, and then we will take the same lessons and apply it to our brownfield mines. Over to you, Joe. Do you have any thoughts?
Yeah, I think when I think about greenfield operations, this is new mines that are being built. The job of the team running that is actually to get production out. They need to actually pour some gold. They need to get some ore out of the ground. They need to actually convert that to money into cash, so they can actually pay for all the investment up front. But also from a digital point of view, it's probably digital technologies may not be the highest priority at that point. But you want to make sure that when you are ready, and you've got stabilized and you've got some cash flow and all the projects are back on schedule again, and their stakeholders are happy, you want to be able to lift that capacity through that process, and you can be able to take those technologies through those things. The other thing about greenfields is that generally the people constructing and building and starting up a greenfield operation is not the people operating it. And so you have different teams of people, and you want to make sure that decisions that are made in the design are actually going to be ready for the people who are further down the track and going through that process.
Great, thanks, gents. Next question. Where do you see the low-hanging fruit for the application of MPC across plant equipment?
Want to take that,
Joe? I'll take that one. MPC is not my subject area of expertise, but really I think when there's a lots of different pieces of information that operators can put information, there may be a lot of set points of how much power they use, how much water they use, how much feed that they're going through those processes, all these particular combinations that have different interactions. It's very difficult to have a simple rule that says, I'm going to put my value at this particular value to be able to go through that process. And what MPC is doing, or model predictive control, is trying to model that process of what's happening. And it's a study and being able to demonstrate and control those areas to make sure that you're actually focusing on the bits that the business is actually is thinking about. And that may be production, or it may be cost, or it may be how much how much carbon dioxide is being created by your industry. So there's opportunities to put MPC to better control processes that are meeting target productions, but it's actually doing it at a lower decarbonisation footprint.
Yeah. And typically, we have observed that every client where we have actually implemented MPC after a study, the return on investment has been within 2 years. So the project pays for itself within 2 years.
Great, thank you. Now, digital transformation is often, there's an importance placed on it being all about the data. How do we know the data is good and then we can trust it?
Look, I think there is a very layman's answer and there is a technical answer. The layman's answer is, would you trust your life with it? That's a very simple way of saying it. But if you become a bit more technical, it's about, data is all about being able to be specific, to be able to measure. This is important. The ability to trace the lineage of data is important. So for example, when you have, say, a model predictive control being used at a mine site to control a process, the data, it is working in a closed loop. So that data, it is in a closed loop system. But when you introduce other variables into a plant, for example, variables which are outside the closed loop, you want to be able to measure the data. You want to be able to trace the lineage of the data. Where was its origination? Has it transformed on the way coming into a report or into a AI model on which a decision will be made? So it should encompass things like accuracy, completeness, consistency, and timeliness, and obviously relevance. So for example, if you look at a Sandvik large haul truck, it generates more than 20,000 pieces of individual information every minute. That is a lot of information coming through. So relevance is important.
And so just part of that data side of things is that in mining, we don't always have all the data. We don't really understand the ore body underground until we dig it up and start processing it. So sometimes that data, we need to know, have the business processes that say that we can actually take that data and then have the ability to be able to reconcile what we've dug out of the ground and actually what we've recovered from that process, to be able to reconcile that back through so we can actually make better decisions tomorrow using the information that we have today. So as the mine goes through its operation, we will find that we will learn more about the data that we have, and the people who started and said this is where the ore body is going to be, there was an approximation and assumptions made in those processes. Let's understand those assumptions and let's actually take that forward so that we're actually acting on the right data that we have and have the business processes to be able to go back and change where we need to.
Great, thanks very much, gents. That seems to be all the time that we have for audience questions. I'd like to give a big thank you to Kumar and JT's with us today. A recording of this webinar will be circulated to all those who registered and will also be available on the OSMine website and our YouTube channel. If you have any further questions for the presenters, please contact us here at OSMine and we will put you in touch directly with Joseph and Kumar. Thank you to everyone who attended, and we look forward to welcoming you to the next OSMine webinar.